In this question, we are given the equation of a circle, and first off, we need to find the coordinates of the center and the radius of the circle. So for this one, you need to know that completing the square is the way. In order to complete the square, I'm going to put the x terms together, and I'm going to put the y terms together to make it a bit clearer, but you can just do it straight from the first line. To complete the square on the x terms, we need to take the 6 and we need to half it. Then we need to square it in the bracket. Then it's going to be minus, always minus, that 3 squared, which is 9. We do the same thing for the y term, half the 10, which is 5. Minus, it's always minus, 5 squared, 25. With the 9 on the end. And once we've done that, it's just a case of simplifying. So I'm going to take the x bracket, I'm going to take the y bracket, put them next to each other. I'm looking at the numbers, the 9 and minus 9 disappear, and this 25 jumps to the other hand side. So from this, you should be able to read off the answer. Remember, the center is always the opposite of the numbers next to x and next to y. So the opposite of minus 3 is 3, and the negative of 5 is minus 5. So the center is 3 minus 5. And in the general equation for a circle, r squared is here at the end. So the radius isn't 25, but it's the square root of that. So the radius is 5. Now for part B, which is a bit more fun. The circle is cut by a line y equals kx at 2 distinct points, here and here. And we need to find the range of values for k. There's 2 ways to do this, and we can use either the original equation for the circle or the factorized one from part A. I'm going to use the top form. And what we're going to do is we're going to substitute y in. So y is kx. So instead of y squared, I'm going to write kx squared. Instead of 10y, I'm going to write 10 lots of kx. That's because these 2 distinct points where it's cut is where the 2 equations meet simultaneously. From here, I'm going to expand out, so k squared x squared and 10kx, like this. And if I factorize out x squared at the front, and if I factor out x for the second term, I hope you'll get an idea of what I'm going to do next. Whenever you see a quadratic and it's got an unknown letter, k or m, whatever letter it's going to be, chances are we're going to be using the discriminant. So b squared minus 4ac, our old friend. In this case, it cuts distinctly twice, so the discriminant is bigger than 0. Now it's a case of summing in, expanding out, and seeing what we get. So b squared is 10k minus 6 squared. A is 1 plus k squared. And c is 9. And this should be bigger than 0. If I expand out that first bracket, I'll get 100k squared minus 120k plus 36. And then I'll minus 4 lots of 9 plus 9k squared. And again, still bigger than 0. If I just scooch up here, I'll now expand that last bracket. So all the first terms were the same, and then at the end I'm going to be minusing 36 and then minusing 36k squared. Now we can start to simplify, cancel down some terms. So 100 minus 36 gives us 64. 36 and minus 36 disappear, and we're left with 64k squared minus 120k. You can factorize straight away, or you can divide, completely up to you. I'll divide to get rid of some of these terms. And once we can't simplify anymore, now I'm going to factorize. So k on the outside, 8k minus 15 in the middle. Now you can't just say that k is bigger than 0 and 8k minus 15 is bigger than 0. You have to draw a mini graph. So 0 is one of the roots and 15 over 8 is the other. Quadratic looks like this, and the quadratic is bigger than 0, which means it's above the x-axis here and here. What that tells us is that k is actually less than 0 on the left, or k is bigger than 15 over 8 on the right. And that's the range of values for k that we're looking for. Here are some more to try.